Hello and welcome to this video lecture on Chapter 4. Today we'll be talking about hardware and software, some open source alternatives, and we'll look at the certain terms and different fundamental computing concepts. We'll also look on some new developments such as the self-driving cars, 3D printing, and the Internet of Things. Sometimes you'll see when you're reading articles it'll say IoT for Internet of Things. And then we'll look at the importance of web applications and mobile systems. Some questions you should be able to answer by the time you finish this chapter is what do business professionals need to know about computer hardware? You know, we don't think you're a computer science major and you're probably not that interested in hardware. But as managers, you need to keep up with the different technologies that are coming out for hardware so that you don't lose a competitive advantage or find yourself at a disadvantage because of the hardware that you're using in your business. You should also be able to answer questions about software. And what do you need to know about software that's coming out in your business, in your industry? And then lastly here, we'll be looking at open source software. You know, is that something you can replace the software that you're currently using, and will it do just as good a job? And it probably won't cost you anything in terms of purchasing the software, but it will cost you in terms of maintaining that software. So in terms of answering the first question is you probably need to be aware of keeping up with the CPU or the brain of the computer. You might hear terms such as dual processor or quad processor, and these are the number of processors that are on a chip. And so when you buy a computer, you'll probably see something that says it's a quad processor, or it might have 8 processors on a chip. But the more processors you have, the faster processing your computer is going to be able to do. Think of each processor as a little computer, and so if I can send instructions to each little CPU separately, then once they get done with that, they can combine the results and show that back on the screen to you. And so to you may not realize that it's being handled by different processors. You just know that it seemed to go faster. So, you know, the latest I think is 4.4 gigahertz in terms of speed and how fast the information can move on those chips. Again, it's just something you need to keep up with. With those chips, there's also memory that you have to buy, and that memory is random access memory, and the more memory that you have on your computer, the more applications you can have open at the same time, and that will have an impact on the productivity that you're getting in your workforce. As we continue to talk about hardware, you also have to think about, okay, I've got everything in RAM, and RAM is volatile, which means when you lose electricity, all that information goes away. So you need to have some place to store it. So the non-volatile storage areas that you might have are hard disks. You might see solid state storage. A lot of times it's just referred to as SSD. And so now you can probably get an SSD drive, 500 gigabytes for maybe about $160, $175. There's also thumb drives. Sometimes they're the USB drives. They refer to the same thing. You also have optical discs, CD, DVD, and then you have what I mentioned earlier. The main memory, or that RAM, is volatile. And so when you lose electricity, it goes off. And so they're working on different things. Sometimes you can buy laptops that might have the operating system program onto a chip, and so then that loads a little quicker. And so it's all about how fast things need to work in your organization. But a lot of manufacturers now are moving away from magnetic disks that have a spinning platter to something that's solid state storage. It's kind of like RAM, where it's saved on a chip. and then it can be changed, but you can't physically move files around in different places on that solid state storage. So once you save it, it's in that location. Here are some different things that you might see coming into your organization when a company talks about personal computers. That might be an Apple, a Mac Pro, could be a desktop that's a PC. We have different types of tablets that are out there. There's a Chrome tablet, there's an iPad. With these things, it kind of depends on the operating system that you're using. So you have iOS 9, iOS 10, so on. Is the data that you're creating able to be transferred from one operating system to another? And so that's one of the reasons you get into problems with Macs and PCs. You can't easily transfer that data. Now, they've taken steps in terms of if I'm using, say, Office on each one of those machines, it saves the files that are created are saved in a format that each of those machines can create. But sometimes you still get little hiccups and they don't work as they should. Some other hardware types you might hear of are phablets. This might be a combination of a smartphone and a larger screen of a tablet. Your smartphones, any kind of servers, these are going to be more of your desktops, and they're going to provide lots of capacity to serve up to multiple users. You might use those for a database within your organization, or you might use it as a web server. If you combine all your servers together, then you would have a server farm. And so if you're a company like Google, then you're going to have lots of server farms all over the world that are serving up information. My thing here would be is as managers, you need to know what kind of hardware your employees are going to be using, what kind of hardware are you going to allow into the organization, because once you allow that in, your employees are going to want to use those devices to do their work, which means if they're allowed to do that, then you're probably going to need to provide some support for those devices. If things aren't working properly, if things get lost and so on. And so then that becomes a huge issue in terms of how many devices are you going to support? Are you going to support all kinds of computers? Is it going to be a Mac and a PC? What operating systems can you transfer your data back and forth to? How are you going to train people in order to do that? Those are the sort of issues that hardware is going to have an impact on you and your business. Here's an example of a server farm. As you look at it, it's just racks and racks of servers, and they're all interconnected. So if one goes bad, typically you can just pull one out and stick another one in, plug it back up, and reload the data that was on there. But somebody has to maintain that and back everything up. When we start talking about data, the lowest form of data you could have on a computer is these binary digits. They represent different pieces of information. So you can think of magnetic spots or integrated circuits that are turned on and off. If it's on, it's a 1. If it's off, it's a 0. If you're using a CD or DVD, it's usually some kind of reflective pit or light that's being read, and so as it reads those reflections, it can represent that data as 1 or 0. Used to be when I had this class a long time ago, they actually would give you binary code and you'd have to translate that into what letter of the alphabet was that, and it maybe even type out a little note. And so that's not the case anymore. It's just to give you some understanding of, at the lowest level, that's where it starts, as with these bits of zeros and ones, and that eventually represents a character. So typically 8 bits will represent a byte, and 1 byte represents a character. When we say character, it's something on your keyboard. Then if we take a kilobyte is 1,024 bytes. And then 1,000 of those becomes a megabyte. And 1,000 of those becomes a gigabyte. 1,000 of those becomes a terabyte, roughly 1,000. And then after a terabyte, we have a petabyte, and then we have an exabyte and a zettabyte. And so this is the hierarchy, and not hierarchy, but the level of growth in terms of describing the size of this data or this file that you might have, or the amount of data that's stored on a particular disk. So they may be different Word files, text files, photos, recordings, so on. And so we're now getting into, it's common to have terabyte drives to store data on your local personal computers. If you're Google, then you're working in probably this range or greater in terms of the amount of data that you're handling on a daily basis. Now, I went to a retail conference about last summer, and a Walmart representative was there, and they were saying that, how much information do they collect in a day? And so it's probably around 2.5 petabytes of information. Now, what can they do with that information? Well, they have these rooms that they can go into, and they can actually display what the sales are for any given product in any given store at any given moment. And so if they see that sales are dropping off on something, they can click on that, then they click on the store. They can even get it to the point where they can turn on a video camera and see, if a certain item or a piece of produce was selling or not. And I remember the lady saying, a manager got into one of these rooms and drilled down till they could see the produce on the store, and then they noticed that that's the reason why the sales weren't going or were dropping off, is because there were none of that produce out on the shelves. So they called up the manager and got them to put more produce out there. But it just gives you an idea of what we're able to do when we're collecting all this data and how we can use that to manage our businesses. So things that you might be looking for is, okay, how much data storage do your employees need? So if you got a solid state hard drive, you might get a 500 gigabyte SSD. And then we talk about CPU speeds in terms of hertz or gigahertz. And so here we have, you might see signs of 3.45 gigahertz as your processor speed. How much RAM? Typically, you might have a base of 4 to 8 gigabytes of RAM. If you're running some high intensive type of applications, they may need 12 gigabytes of RAM. And so the way that works is your RAM actually loads the application into memory, and so now it's all with those integrated circuits. And so if you have large applications and large data files, you're going to need that in order to be able to manipulate that. You don't want to have to keep going to your storage device to read and write information as you're working on your application. So moving on to answer questions about how can hardware affect your competitive strategies. You might want to think about what kind of smart devices are you using? Are your competitors using them? Smart devices allow those devices to automatically connect to the internet if it's available. They can interconnect with each other and share information, and that might give you an advantage depending on what you're doing. Now, that also opens up some potential problems in terms of security. If that's going through Wi-Fi and you don't have it encrypted, then somebody might be able to listen in and capture all that information that's going in between and see what you're sending. Now, with those devices, there's a potential that they're going to be disruptive to organizations or disruptive to the industry. I was reading something earlier that was talking about phones and the design of phones. Well, when the phone comes out, it's probably got different features. Well, that's not disruptive to the industry. It's just a function, and soon your competitors will catch up. It doesn't really change how things are done in the industry and stuff. And so when you think about being disruptive, it means it's going to change how we go about doing things. And so you hear a lot about the Internet of Things, and so that's actually putting the capability of a device to connect to the Internet, to share that information. So cars have that in there. You have phones, watches, even have, I heard from, I think Under Armour was thinking about putting in certain types of chips and sensors into their shoes so that it would automatically track when you started running. You wouldn't have to open up your watch and do a lot of programming to get that going. So those sort of devices, the Internet of Things. Now, they might be disruptive to the organization in terms of how the organization is doing things. Something that's probably going to be disruptive to the auto industry, and there's be new ways of doing it, is the self-driving vehicles. They've got them working fairly well now, but there's still some problems when they have crashes and wrecks, and they eventually get that programmed into their systems, and then that'll start to work. So 20 years from now, maybe you just get into a vehicle and it works like a taxi cab. There's nobody up front. You tell it where you want to go, you slide in your credit card, and it takes you there. Or if we're using interstates, again, you'll just be sitting in a vehicle. All the vehicles will get up to a certain speed, and it'll be one right after another, and you can work or sleep or do whatever you want to do while you're being transported to wherever you need to go. There's also 3D printing. We can now print objects. We have to have a program that describes that object so it gets printed. But 3D printing is also being used in the healthcare area. You can actually print skin or print devices that might be used inside of a human. Now that might be disruptive to the medical industry in terms of how they go about doing things, and it may relieve some organ transplant lists and all the processes that have to go on with being able to acquire an organ from a patient and so on. So here we have a graphic of how the evolution of the phone and communication has taken place. So initially letters, then we have a phone, then we have a phone that's you're not tied to. It actually sends a signal back and forth to the base. Then we went to a wireless phone, and now we're going to tablets that can be used for communication, whether it's text or voice or video. The next item to discuss is the self-driving cars. And so we have this in some cars today where they can parallel park, and that is hands-free. And so hopefully that will cause less wrecks and damages to other cars. Hopefully also reduce this human error. And long term then, hopefully that will reduce traffic tickets, parking tickets. If the cars are all sending out signals and they can detect where a parking place is, they might be able to send that signal to nearby cars, and then the cars would know that there was an open parking place, and they could actually instruct the driver to drive there, or if it was all automated, go ahead and drive it there and go ahead and park in that empty spot. And so again, we're using not only that technology of self-driving cars, but that Internet of Things as well. Now when that finally happens, the question is how will that disrupt business? Well, it could mean there's fewer cars on the road, which would then mean there's fewer cars sold. currently households have multiple cars. They have multiple cars because each person in the household may need the car, but what if a car could be used to drive a person to work and then return to pick up the next person and take them to work as well? Then the household wouldn't need multiple cars. That might also have an impact on auto loans, insurance, and your total car repair bills. Right? Now that might be a downside in terms of sales, but now we've got these cars that are automated. They need to be maintained a little better. And so that means there's probably going to be more jobs for engineers, programmers, and designers. And there's going to be more sales of computer hardware, sensors, and cameras in those cars. And so there may be a trade-off from one area of the industry to another. Another area that's having an impact on the industry is the use of 3D printing. These printers can actually print with plastics, metals, foods, and biological materials. And so now we can print, maybe we want certain decorations on our foods. If we want biological materials, it might be skin for burnt victims and so on. And the nice thing about this is maybe we're just experimenting with different designs of our products. And so instead of having to go out and contract with an organization that does a one-time design, we can actually design it and produce it ourselves, which is going to save some money. So that would have opportunities in these areas like aerospace, defense, automotive, healthcare, right? And maybe, what if we could actually 3D print large objects? And I've actually seen things on the internet where people would print a house. So if you had a big enough printer, you would print, say, blocks, maybe 2 foot by 2 foot blocks for the house, and then they could be assembled just like a Lego building would be. Right? So, depending on what we want to do with 3D printing, we now have the ability to be our own manufacturers. So here are some examples of 3D printing. You have ChefJet that produces little customized desserts. You can do living cells, whether again it's organs, bones, heart valves, skin. You even have some house buildings that are all done with 3D printing. So I'll go ahead and show you what those links are so you can actually see them. And I'll probably move this up the screen here. But as you can see, these objects were printed with 3D printing, and they're little sugar objects that could be used in the coffee. And so you can print other things. And so here's what the printer looks like. You put in the program and then hook up to whatever you're going to use as your product, or what am I looking for? The actual substance that you wanted to be printed with. And so you'd have to buy that and put that in that printer. But this gives you an idea of what is happening. I'm not sure that would be disruptive to the catering business or the high-end restaurant business, but it might be a novelty at first. It might be something to attract more customers, and if you didn't do this sort of thing, you would find yourself at a disadvantage for a while until that novelty wore off, or at least you caught up with them. So then in terms of using this for printing out living cells, you can see here's what that printer would look like. Again, you'd have to give it some kind of substance in order to start printing that out. So it might actually print out something like this. Okay. Could it print somebody's ear? Might be able to. If they got it sliced off or an accident or cancer or something, they might be able to replace those body objects. And then if we look at a house manufacturing, So this is just a diagram of what it would look like, but a house could be actually 3D printed. You have this large mechanical system, and the bar slides across this way, and then you have a track to go this way, and then it would actually just put on a layer at a time of concrete until it got the walls and everything built that you wanted. So that might be disruptive to the housing industry in terms of making things a little bit more efficient, and so it might make things cheaper and more affordable for people. So some other things that you can go out there and look on YouTube, you can see the driverless Mercedes-Benz. You may not have a name brand Nest, which is a thermostat that you can have for your home, and it kind of learns on how you use your thermostat, what temperature you like your house at certain times of the day. It will learn when you're coming home, and then it will start setting those temperatures for you, and you won't even have to change those. And then that device can also work via an app on your phone, and you can control it from anywhere in the world. So you can go and look at these YouTube videos that are out there that actually show you how to do 3D printing in metal, wood, and stone, and so on. I know in the entrepreneurship program here, there was a former student who wanted to print out certain things in metals, and so I think he demonstrated how that would make it more efficient for different manufacturing companies to actually prototype something without having to go and contract that out. They could see directly if that new product, that new design was going to work or not for them. So the next question to ask or to be answered is, what do business professionals need to know about software? So you need to know about the functions of the operating system, the servers, and applications. So which one of those different types of computers do you choose? What kind of software do you need to use to go onto that computer? Then how do you go about choosing something? And so here we look at there's client and server type of hardware, if you would, or technologies. The internet is actually a client-server network, and so you have clients that go onto the network and ask for information that's delivered back from the server. Your browser that you use is a client, and that server is a web server somewhere sitting out there. And so locally, if you're not serving up anything, then you are the client, if you will. That's how you think of it. And you're going to need certain programs that run on the client, and all the processing is done there. Servers actually serve something up, and that sometimes that processing is done there. So if you're doing any kind of e-commerce, you're probably going to have some web servers that are collecting that information and processing those transactions. So here are some examples of operating systems that you may hear about. So Windows, we have Windows 10 now, Mac OS for Macintosh computers, Unix, Linux. These are kind of older systems, especially the Unix workstation clients when they work on. If you're using Windows, that's a PC or personal computer. Mac OS runs on a Macintosh. And so you're going to need different types of systems, application software to run on these. Even though they might be called the same, they're totally different on how they're written. And so if you're running Office 2016, you're going to need to buy a version for Windows. You're going to need to buy a version for Mac OS. And if they have some for these other operating systems and you're using those, you're going to have to buy that software for that particular operating system. Now on the previous slide, they were talking about non-mobile devices. So with mobile devices, you might have operating systems that might be called Symbian, BlackBerry OS, iOS, Android, Windows 10, which runs on their phones and stuff. Again, you might have servers here. You have Windows Server, Unix, and Linux. And this is special software for these type of servers. Now these aren't mobile operating systems. These are for big machines again. Now when it comes to hardware these days, and you're wanting to run multiple operating systems, you can use the same hardware to do that. And the way you do that is with this concept called virtualization. So if you'll recall, we talked a lot about RAM. And so if you load up a server with a whole lot of RAM, I mean hundreds of gigabytes of RAM, then you can virtualize in that RAM different computers, if you will. They become their own little computer within that RAM. And so it's called PC virtualization. You can also virtualize servers. So one piece of hardware, if you remember we saw that server farm earlier. So within that one hardware box, we might have 4 or 5 different servers that are running on that operating system. And each server could be running their own operating system. And so you can do the same thing with desktop virtualization. So we can actually have one big server that's serving up to multiple clients different desktops. And so that's another way that your organization may operate and cut expenses. And so it's something the university here has thought about. What if you could just log into a browser to a desktop virtualization and have access to all the applications that were installed? And so that would eliminate having computer labs. It would eliminate issues that you have on making sure that application is running properly on all the different types of computers we have. They'd just be all virtualized and you would access them through your browser. And so that's what virtualization can do for you. You multiply the uses that you can have for your hardware, and you can have different operating systems running on that one piece of hardware within the virtualized environment. So for those of you that are running Mac computers, what you could do then is virtualize a PC and actually be running Windows 10 on your Mac and a virtual PC. And you would just set it up just like a regular PC, but you'd have to initially access it from your Mac computer. You'd open up the virtual PC and then it would just look and feel and operate just like you're working on a PC then. But again, you're going to need lots of RAM in order to do that, and you're going to need some fast processors. So here's an example of the screen from Microsoft Hyper-V Manager, and so that does the virtualization. So they're actually virtualizing a server within a hardware server, and so it allows you to have multiple computers inside of one computer. Think of it that way as well. So each virtual machine is going to have disk space and other resources that it's allocated to. So those other resources mean it's going to have its own RAM, its own processing power, and so on. So wherever this is loaded, then that host operating system controls all those activities of the virtual machine. Here's an example of how a virtual machine might be accessed through a web browser. So you just put in the address, it takes you to the machine, and then it works just like a regular machine. You wouldn't know the difference between a virtual machine and a physical hardware machine. Next thing I want to talk about is the difference between a license and a site license. And so when you purchase a program, you may not actually own it. And so what you're actually doing is purchasing a license or a right to use the program. And so there's also some end user agreements where it might limit the vendor's liability in terms of what that software might do to your physical hardware or your data. And so then there's this concept of a site license, And that means when a company buys that, they're paying a flat fee to install that software on all their computers. And so the site license is for a physical computer use, and so I can install, let's say, Office on all those computers. Sometimes a license might be for a person, but I think the industry has gotten away from doing a license for individual users and more towards each individual computer that software can run on. Then there's also software that you can go out and download for free, and it's open source. There's no fee for it, but you have to agree to use it, and if you make any changes, you have to agree to maybe make your changes available to the community, so they might either test it, or somebody else who has a use for the changes that you've made, so they could use that. Another thing you should be aware of is the different software types that are out there and their sources. So sometimes you get a horizontal application, and that would be off the shelf. So everybody in the organization kind of uses that. So it's kind of like general purpose software, so something like Microsoft Excel or Word. Vertical applications that can go between different levels of an organization. You might have off the shelf that you can buy, and then you might be able to customize that somewhat. So then there's this one-of-a-kind application. This is where you would have to have it developed in-house. So there isn't software out there that does what you want it to do, and so you would have to develop it for yourself, and it's customized, and this is going to be much more expensive than off-the-shelf software. So think about, if you had to write your own word processing program, how expensive that would be. But because somebody else already did it and they can sell it to millions and millions of people, that reduces the cost. And so the costs in these type of applications, the off the shelf, they're going to be much less than something that's customized. Another thing you might be exposed to is something called firmware. And firmware is software that's been written into a chip, and so it doesn't get changed. It's hard or difficult to erase. Now when it's only written into a chip and you can't change it, it's called read-only memory. And so sometimes your printers, your print servers, any kind of communication devices have this. Now occasionally you may need to upgrade the firmware, and they can send you out software and special program that will be able to do that. But you typically don't want to do that unless you really know what you're doing, and it's something for an IS professional to be doing. So continuing on with talking about different types of software and different alternatives is this open source. And so there are certain off-the-shelf packages that have been written in open source that's available to the public. You just have to agree to make your changes available to others and sign an agreement that you won't use it for profit. So you can't just go out there and download open source software, change the name, and start selling it like it's yours. You would get into a lot of trouble for doing that. But there are, here's some examples. There's LibreOffice, which is a office suite for Linux distribution, so you need to be running this operating system software. For Windows machines, you can go out there and look and see if there's something called Star Office. It's very similar to Office. Has a lot of the same functionality as Microsoft Office, but not quite the same. The file formats that it produces are compatible, so you could read and write them into Office if you needed to. Some other open source software: Firefox, a browser, MySQL, Apache, which is a web server software. A lot of the industry uses Apache servers for web servers. Ubuntu is a Linux type of operating system. We have Android operating systems, and there's different names for the different versions that they have. If you're running Cassandra, You might need that operating system to run some special database management systems, which we'll talk about in Chapter 5. And one's called NoSQL, and this is what a lot of your search engines are running as a back-end database, and so it works a little bit differently. If you're going to do any kind of big data processing, there's something called Hadoop, and you would learn about that if you were a data analytics professional. So you may be asking yourself, why do people give away free software that's almost commercial grade or is commercial grade? A lot of times these people just want to help. They think that the for-profit software companies are making way too much money, and they want to do something to help people that don't have this kind of money, especially people in other countries where obtaining this software might be very difficult and even more expensive to them. It also gives them some notoriety if they're heavily involved in a project and have done something good for that project. And so those are some of the different reasons why people might want to get involved in an open source project. So an example of the results of an open source project might be OpenOffice. It's very similar to StarOffice. So how does open source work? So it works like typical programming would do. You would actually write the source code, and so that's done in a text editor. It gets converted to machine code, and then that becomes the software. Now, for proprietary companies, it's only available internally to the trusted employees and certain contractors. Open source software is available to the public, so the public could actually go in here, look at this source code and modify it and use it however they wanted to in their organization, as long as they agreed to the license. So the question is okay, I'm getting this for free, what is the catch? Or is this really going to be long-term and viable? And so it really depends on your requirements and the constraints that the public or the group that's controlling the software has on that. And so a lot of times the software is free, but the support, who you're going to call if you have problems and things aren't working right. So you're going to have to pay somebody to support it, which means they're going to be very specialized and know about that particular software and the operating system that it runs on. So there's that operating costs that you're going to have to also incur. So then the question is okay, I'm having to pay to the support, I'm having to pay for the operational costs. Is that going to be higher than if I went out and purchased a similar product but I had to pay the licensing fee? So those are sort of the decisions that you're going to have to come up with and make. So that ends this chapter, and so hopefully this chapter will give you some understanding of how technology is being used in commerce and how your involvement might take place. We talked a little bit about the different types of hardware and software that are available today, but that's going to change, and so you need to keep track of that hardware and software and see how you might use it in your own organization or business. We talked about application software, we talked about open source software, and what kind of things you need to look for there in terms of making a decision on whether you want to do a license or is it worth paying for that support and the operating expenses for that open source software. Alright, and so that's all I have to say.